Hi, welcome to Math Antics. In our video called Long Division, we learned how to do division problems that had long, multi-digit dividends. The key was to break up a big division problem into a series of smaller and easier division steps. And that involved trying to divide the dividend one digit at a time, digit by digit. And in the examples we saw, going digit by digit was pretty easy because we only had one-digit divisors. But what if you need to use that division method for problems that have bigger divisors, like if you're dividing by a 2 or 3-digit number? In this lesson, we're going to learn how you handle problems like that. The good news is that you kind of already know what to do. You just may not realize it yet. To see what I mean, have a look at these two division problems. They both have the same dividend and both have a one-digit divisor. But these divisors are different numbers, and as you'll see, that's going to affect our digit-by-digit division process. To solve this first problem, we start by asking, how many 2's does it take to make 5 or almost 5? Or you can think of it as how many 2's will fit into 5. And it's easy to see that the answer is 2. So we put a 2 as the first digit of our answer. Then we multiply 2 times 2, which is 4, and we subtract that 4 from the 5, which leaves us a remainder of 1. Now we move to our next digit, and we need to bring down a copy of it to combine with the remainder from the first digit. Then we ask, how many 2's will make 12? That's easy, 6. So we put 6 as the next digit of our answer. 2 times 6 equals 12, and 12 minus 12 leaves no remainder. And finally, for our last digit, even though there is no remainder, we can bring a copy down and ask, how many 2's will make 8? And the answer is exactly 4. 4 times 2 equals 8, which again leaves no remainder. There, we went digit by digit and broke our problem up into 3 division steps, one for each digit. And we got our
Interesting because my calculation for that is incorrect.
answer, 264. Now let's solve the next example. And right at the start, you'll see we have a bit of a problem. When we ask how many 8's does it take to make 5 or almost 5, the answer is none. And that's because the first digit, taken by itself, is less than the divisor. 8 is too big to divide into 5. So what do? Well, instead of just trying to divide the first digit all by itself, let's group the first 2 digits together. If we group the 5 and the 2 together, then our first step will be to ask how many 8's will make 52. That's better. 8 will divide into 52 about 6 times. So we'll put a 6 in our answer line, right above the 2. Why does it go there? Because we had to skip the first digit and group it with the 2. If we wanted to, we could have put a 0 above that first digit, since the 8 wouldn't divide into it any times. And if that helps you keep track of which answer digit you're on, then that's a good idea. But it's not required. So 6 times 8 equals 48, and then 52 minus 48 gives us a remainder of 4. Now we only have one digit left to divide, so we bring down a copy of it to combine with the remainder and ask how many 8's will make 48. We know the answer to that is 6 also. 6 times 8 is 48, which leaves no remainder. There, our answer is 66. Did you notice the difference between these two problems? We wanted to go digit by digit in both problems, but in the second problem, the divisor was bigger than the first digit of the dividend, so we had to start out by going 2 digits at a time in that case. And that helps us see something really important about this traditional long division method. You don't always have to go 1 digit at a time. You can break the dividend up into bigger chunks of digits if you want, and apply the same procedure.
Okay, let's just pause first. That's a bigger number, bro. That's a bigger number. Let's try solving it.
To those bigger chunks. You could go 2 or 3 digits at a time, or even try to divide the entire dividend all in one step. And taking bigger chunks of the dividend usually results in fewer division steps. Notice that there were 3 steps in the first problem, but only 2 steps in the second problem. Fewer steps? I like the sound of that. That seems like a lot less work.